and it's tough for me. It's like really tough. So anyway, this is another one. So you can see how it's kind of wrapped around itself like that. And that would be your Schwann cell right there. There's the nucleus to it. And then, so here's your bipolar, multipolar, and unipolar. So you got one dendrite, two, and multi. Okay? But if you see this never changes. Directional impulse, meaning it's coming in through the dendrites, it's going through the cell body, and then out through the axon. Okay? Sensory neurons are called afferent. They're bringing information to something, okay? So they are bringing usually to the brain or to the spinal cord, okay? Those are called afferent neurons. So they're going, don't get that away from the peripheral nerves. I'm sorry. Never mind. Go back. Erase. They're going from the peripheral nerves to the spinal cord, to the brain, and then the afferent are going to be from the brain to carry out something. So the afferent is bringing it to, efferent away. Efferent are usually referred to as motor neurons because we're looking for a response here. Afferent, somatic, because we're bringing information in, there's no response to that. It's like your receptors tell you it's cold. Your receptors can't do anything about the cold because it's afferent, meaning it's getting information, it's gathering the data. It has to be carried out by the efferent neurons. Those are motor neurons. So my hands are cold, efferent neurons tell me to do this, right? Okay. And then we have interneurons or internuncial neurons. Those link certain neurons, so they're just basically linking neurons. Okay.
So it's like there's between affect and effect.
Yeah. So your
It's like your sensory neurons who can. I understand it, but I would not be able to verbalize it. It's like as in.
Sensory neurons are always afferent neurons, meaning that they're just pulling information in. That's all they're doing. They're not doing anything else except receiving data.
They're just the messenger.
Getting information, gathering information from internal and external environments. And they do that all day, every day, all night, every day for the rest of our lives, our entire lives. Afferent, just pulling in information.
So it affects the brain, and then the brain will.
Effect a movement.
Okay.
Does that make sense?
Mm-hmm.
Okay. Y'all good on this one?
Yep.
Okay. It's a little bit, because the words are so close. I'm sure y'all will probably come up with some way to remember it. So here's your sensory, internuncial neurons, motor neurons, effector. Okay? Get the information has to go somewhere to figure out what's going to be done. Once it's figured out it's done, the response is carried out. I'm not really going to go into the synapse a whole lot. Just remember it's that space between one neuron and another. And the synaptic cleft is the actual space itself. So the synapse is the connection point. The cleft is that little bit of space between the two. And those neurotransmitters are going to jump from one to the other through that little space to the receptors. Okay? Got it? All right. So here's your synaptic cleft. This little cleft right there. This would be the axon of one neuron, the dendrite of another. So right along here, so if you follow the axon down, this right here would be the synapse, where we have one neuron meeting another neuron. Same thing here, synapse, 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 synapse. And then that information is going to go down here and synapse with another one, and another one, and another one, and another one until it gets to where it needs to get. Okay, so this is where that release of neurotransmitters is going to occur, right there. And those neurotransmitters are just chemical messengers. That's all they are. Getting sent. So here you go. These are little vesicles, little sacs of information, basically. And little vesicles are pushed up towards the surface and released into the synaptic cleft. And then once they're in the synaptic cleft, they find these little receptors on the dendrite of the next neuron, and they connect, and then they'll be brought inside the cell. Make sense? And then just impulse keeps going. It's all electrical. It's all electrical. Chemically electrical, I guess. Anyway, there's over 100 neurotransmitters. You don't need to know them all. There are some very specific ones that you guys probably will need to know eventually. I'm not going to get into it because I don't think it's going to be on your test as far as like the different types of neurotransmitters. Acetylcholine is one that you probably will need to know. That's at the neuromuscular junction. So that's when the neuron meets the actual muscle cell, and that acetylcholine is released at that point. Some of the neurotransmitters will excite a reaction, meaning they'll intensify it. Some of them will inhibit a reaction, they'll bring it down, okay? Epinephrine is also a neurotransmitter as well. It's released from the adrenal glands, and it is a neurotransmitter. So these are just a list of a few of them: dopamine, serotonin, histamine. All of those should be kind of familiar with in your brain. At some point you probably heard things like serotonin. That's the happy, feel good, sleepy, fun one. Dopamine is also a feel good one. Causes like never mind.
So when I say action is blocked by LSD, that's talking about like lysergic acid.
I don't think so.
Like the drug, or is that a different acronym for?
I would have to look that up, because I don't know if they're talking about the drug LSD, lysergic salicylate, whatever it is, the acid, or if it's talking about, I'm not sure, because I don't know why they would put blocked by LSD in a slideshow.
And then
Doesn't make
SSRIs are like your Prozac and Zoloft.
Right, right, and what those do is they block serotonin from being taken up, meaning it allows the serotonin to be available more. Basically, it blocks the okay, this right here leads to sleepiness. What do you do when you're really depressed? You want to sleep a lot, right? You're depressed. So the SSIs are going to block the reuptake of the serotonin. So it's going to block that kind of down feeling that you get. So we see these in antidepressants, SSRIs, serotonin, selective serotonin reuptake inhibitor, SSRI.
And is that lysergic acid, is that already a chemical found in the brain?
I have to look it up.
Okay.
I do not know. No. Okay, so anyway, you don't really need to know these, but these would be some of the neurotransmitters associated with the body itself, vasodilation. And this is convergence and divergence. So convergence is where you have two that are coming together, converging into one. Divergent is you have one that's diverging into two. Okay, so it's splitting different ways. Types of nerves: sensory or afferent, right? Sensory or afferent, and those are going to bring the information to the CNS. Motor or efferent, which are called motor fibers. They're going to carry out the impulse that the CNS has determined. Then we have some mixed nerves. That means that they're both mixed, they're both sensory and motor. Now this comes really big into play when I start talking about the 12 paracranial nerves, because you're supposed to know whether they're sensory, motor, or mixed. And there's an easy way to do it. I will tell you my little ways to remember those. But again, sensory is going to bring information in, motor is going to take it out. So it's going to tell you kind of a little bit about the nerve and what that nerve does. Okay, for example, the oculomotor nerve. Wait a minute. Oculomotor nerve is a combination nerve. It is both sensory and motor, and it allows your eyes to move. Okay, that's the third cranial nerve. And it allows you to kind of see vision and move around. Now, the optic nerve is completely sensory. There's no motor to it. You're getting information into your eyes that's being sent to the brain. There is nothing that's going to happen to the optic nerve. You have to, oculomotor nerve is going to allow you to move around and see more stuff. It's like the olfactory nerve. It's just sensory. It's going to turn the chemicals in the environment into a smell. That's what the olfactory is, the second cranial nerve. I'm sorry, the first cranial nerve. Sorry, the first one. The first one is olfactory, second one is optic, third one is oculomotor. Yeah, you'll know more. I promise. Epineurium is the covering, the outer covering, perineurium, and endoneurium. You guys notice that there's 3 layers to a lot of things in our body. Epi above, peri around, endo inside. Those are the medical terms for those. Epi is above, peri is around, and endo inside. So epineurium would be the outermost layer, perineurium middle layer, endoneurium inner layer. Okay? And just like the muscle fiber, or the muscle itself, this is your nerves. Looks a lot like it, right? You remember the muscle fibers with the fascicles into the bigger bundle, into a bigger bundle, then everything is surrounded by a tissue. This is the nerve fiber, so it looks a lot like a muscle. Nerve and muscle look a lot alike. They're not, but they look a lot alike microscopically. Look at it. Okay, we good? Because I'm trying to get through this without using your entire class time, which doesn't seem to be happening. Pathways, we have those quick ones, which are reflex arcs. That's something that you don't need input from your brain to remember. It's mostly going to be preservative impulses, meaning the things that are going to preserve your body from damage or to keep you safe. It's like, how many of you guys go to the eye doctor and they put that little puff of air in your eyes? What happens? You blink. That doesn't need to go to the brain to figure out that you need to blink. It's a protective mechanism. Just like if your toe is burning, you're going to pull it out because it's a protective mechanism. Those are reflex arcs. One of the most common ones that people are aware of is when you go to the doctor and they do the little knee-jerk thing to test your reflex arc. Doesn't need to go to the brain, just happens, okay? You have that sensory receptors and sensory neurons. The interneurons is going to go to the CNS, to the reflex center. Sometimes does not even need to go to the brain. It's usually found in the spinal cord or right outside of the spinal cord, these reflex centers that are going to help us kind of fix things quickly, okay? So you got the sensory, which is afferent, motor, efferent, okay? Receptor, effector, effector. Generally, like I said, it goes to the spinal cord and we're good. Don't need to go all the way up. I'm gonna go past this because I already kind of talked about it a little bit, but here you go. Comes from here, afferent, right? Sensory, internuncial, doesn't need to go up to the brain or anything like that, and then the motor neuron's gonna come back out through the efferent pathway of the spinal cord. Afferent horn, afferent nerve root, efferent nerve root. Comes back around and boom, muscle contracts, knee jerks. Easy. Easy peasy. All right, we're not gonna go over that. It's the same thing. You're stepping on a tack, afferent, efferent. Okay. Meninges themselves, 3 layers. The dura mater is Latin, directly translated into, anybody want to take a guess?
Tough mother.
Tough mother. Did she tell you all that?
I think you did.
Okay, I probably did.
Yeah, I think you did.
Okay, so it is the outermost layer of the meninges. This 3-layer membrane that covers the brain and the spinal cord, and it's real tough and fibrous. So if you remember tough mother, that's exactly why it's called that, because it's tough, fibrous, connective tissue, and basically it covers the entire brain and spinal cord because we're encased in bone, and bone is not necessarily smooth. It has like some rough edges to it. So we don't want the brain tissue itself to be exposed to that. We also want to have a little bit more protection than we might need otherwise, because the brain is kind of a jelly-like consistency. It's not what most people think. It's kind of like pudding almost, I guess is the best way. It's a little bit little bit better than that, but it's pretty mushy. So we want this deep connective tissue that's thick. It's very, very vascular. So if you're doing any type of neurosurgery, when you get to the dura, you better have some gel foam and thrombin ready because it's going to start bleeding. And we'll also use bipolar forceps, which are like a monopolar bovie, but with 2 tips, so that we don't actually have to go through the whole patient because we don't want to disrupt electrical flows. Forms the interior periosteum of the bones, but it also folds over the brain and follows it. So this is the outermost. The next one is, you guys know? Arachnoid, spiderweb.
Go ahead,
And
Gina.
the final one is
Pia matter.
pia. Now, the thing to remember is the pia itself adheres directly to the brain tissue. So when we're talking about spaces, we have no subpial space. And this becomes really important when talking about brain surgery or spinal cord surgery or any type of surgery. You've got the dura, arachnoid, and then the pia, which is actually going to adhere to the brain and actually goes into the fissures and stuff like that. And there's different areas of it. But you've got dura, arach, pia. Okay. So if I have a blood vessel rupture and it's bleeding here, what would that be called? Remember my hyper's below. Where are we? Yeah, hyper's. Oh, hyperstance, sorry. Hypo is below.
So, what was below earlier was subdural.
Okay, this is epidural. Epi above or upon. So if I have a bleeding going on right here, it's between the dura and the skull itself. So I am actually on top of the dura in between the skull and the brain tissue or the spinal cord itself. That's called an epidural hematoma. Hematoma is just bleeding or bruising, which is bleeding, okay? This is easy to fix. We just make a burr hole in the skull, we just burr hole in it, and we suction it out, flush it out, and it's all good. We just make 3 burr holes, 2 on the top and 1 below, and we just get the aseptors and just flush until it comes out clear. We're done with our epidural hematoma, right? If it's here, what is it called?
Subdural.
Subdural below dura, subdural hematoma. If we have a subdural hematoma, what are we gonna have to do? We're actually going to have to go through the dura. So this is a little bit deeper. It's more dangerous and it's a more involved surgery, right? Because we can't just make a burr hole and flush it out. We've got to make a burr hole, possibly turn a flap, cut through the dura to get to where we need to go, and then fix it that way, and then sew the dura back up and seal it. What if it's here? Subarachnoid. What do you know about that space right there? CSF. So at this point, we're going to have CSF involvement. So it gets even more serious. So the deeper the bruise, depending on the layer of the meninges, the more serious the surgery is going to be. So some of them can be very serious, some of them not so much, but you always want to make sure that you know where you're going first. Because if your surgery schedule says emergency subdural hematoma, you need to make sure that you have like everything that you need. Okay. So dura, arachnoid, it's a very thin layer. It's kind of web looking, which is why it's arachnoid, which is Latin for spider. And then pia is the internal one. Follows your contours. Here we go. There's your spaces and uses your sagittal sinuses. This is where we've got some CSF flowing. You can see these darker areas, CSF, brain tissue, cranium, which is the scalp. We also have this thing called a galea, which is a big fibrous sheath that sits on the top of the head and actually holds the scalp to the brain. Galea, galea. So anyway, this is just a nice little, you can see how the pia itself is actually following these little holes into the brain. Pia is going to go all the way down in here, just like that. And then the arachnoid is going to go down a little bit, but not quite as much as the pia. And then there's your CSF flowing between the two, all the way down. Spinal cord. Okay, so I'm really not gonna go into this picture that much because I don't think you need to know it, but you got the body right here, you've got this, the spinal process, which is here. You also have pedicles and other things, which I don't think you need to know for this because it's about the spinal nerves and not the bones themselves. Those we'll get into when we're talking about neurospine. So again, we're going down, we've got this inner cord. We've got the meninges, the 3 layers of meninges. You've got your spinal fluid that's flowing around it. And then you have these roots coming up. You've got a ventral root and a dorsal root. Ganglia or something else completely. We're not even gonna go into that. Okay, spinal cord begins at the foramen magnum, right here, right? And then it goes all the way down to about L2, R3, at which point it starts to kind of splinter off into what we call the cauda equina, which is Latin for horse's tail. That's because it's no longer a single cord, it just starts to kind of spread out a little bit. Okay, go through this. There you go, here's your cauda equina here, about L2, 3, and boom, boom, boom. But your spinal bones themselves are very easy to recognize. Yeah. All right, I'm gonna have to take a break.
Yeah.
I know you don't have a test, I'm sorry.